Proceeding further from the discussion of the last class, we were discussing how to handle angular momentum in case of pure rolling motion. And we have this thing in front of us. If you look at this tick mark, sigma is for I. You find that things are very easy. I mean, this is not going to depend on I, RCM. VCM is not going to depend on I. So this fellow is same as writing sigma mi completely outside, then RCM cross VCM. And sigma mi is the total mass. That's the thing for this fellow. Now this tick mark, if you see, here we are talking about center of mass, And if you sit at center of mass, then pure rolling looks to you as pure rotation. Pure rolling looks to you as pure rotation if you sit at center of mass. So this fellow is what angular momentum B with respect to center of mass observer, this whole thing. So I'm going to write 4 lines, 1, 2, 3, 4. Second line is this. Third line is LCM implies it is with respect to CM. It is with respect to CM. It is not of CM. It is with respect to CM. This fellow, you can say, is of CM, center of mass. It is just like saying that imagine the whole capital M mass to be placed at the center of mass and just visualize it as particle and handle its angular momentum. So this is like translational representation. A particle kept at the center of mass having the mass equal to capital M. And this is about center of mass, and about center of mass it looks like pure rotation. So you can say this is representing the rotational behavior, this L. And that L is showing the particle behavior, translational behavior rather. Other two we expect to become 0. But we must have sound reason for that. Let's handle the 4th line first. You see, VCM does not have any I in it. Sigma means I. So I can write VCM out of sigma notation. I can simply say that consider these two fellows inside sigma and take that VCM out of sigma. In the first row also, there is RCM which is not inside sigma. I mean, which doesn't have to be inside sigma. It has no I in it. So if I choose to write RCM outside, then inside it would be MI, then VICM, but cross product is there. Cross product I can put here. Cross. Scalar can go to left or right side of cross product, no problem. Mi is a scalar. Now focus on this. Supposing we divide it by total mass and we multiply it by total mass, then what is this going to be? M1 V1 M2 V2 plus M3 V3 whole divided by M. Is it not going to be VCM? But this VCM is with respect to CM, right? What is VCM with respect to CM? Gone. So this thing is gone. Now look at this. We divide by capital M. We multiply by capital M. Now M1 R1, M2 R2, M3 R3 and so on, whole divided by M is what? RCM. But what is RCM with respect to CM? Again 0. This is RCM with respect to CM. Position vector of center of mass with respect to center of mass. Because this part is 0, this whole thing is 0. Because this part is 0, that whole thing is 0. So we are left with only two fellows. One fellow is showing us the translational behavior, which is MRCM cross VCM, and the other fellow is telling us the rotational, which is this, with respect to CM. Very important to that.